Hello guys, and welcome back to another class of our course about the complete introduction to quantum computing. So in today's class we are still going to talk about mathematics and we are going to talk about linear algebra as well. So basically pretty much the same thing as we talked in the past few classes. Today what we are going to talk about is pretty simple. So we are going to have an introduction to matrices, and I'll show you some operations that you guys can perform with matrices, basically what it's used, and we are going to understand basically what is the difference between matrices, scalars, vectors, and all this stuff. So let's start. All right, so basically what exactly is a matrix in linear algebra? So basically a matrix is a rectangular array of numbers, or it can also be symbols that are arranged in rows and columns. So basically, let's say we have a matrix with x rows and y columns. So it's going to be an x multiplied by y matrix. So here you can have an example of what a matrix is. So basically we have in this case three columns and three columns and two rows. So basically this is an example of matrix. It can have way more columns and way more rows as well. Another thing, a scalar. We don't have scalar right here. So basically a scalar is just a number inside of a row or a column. And a vector. So basically a vector can simply be a column or a row. So in this case, a vector will be 6, 1. Or here we'll have a three-dimensional vector. So since we have three numbers. So basically here we have another vector, so basically 6, 1. And we saw in the past few classes how vectors looks like on a graph. So where exactly matrices are used in real life? So they can be used in many fields. Those fields can include, for example, statistics, finances, research, or scientific studies. And as I said, in pretty much any field, scientific studies. Matrices can also be used to represent real-world data. So when we're talking about real-world data, we can, for example, think about the population of lions in Africa, for example, or I don't know, the quantity of pizzas created in a restaurant. So basically, anything that can, anything that uses numbers and statistics and counting. Basically we can work with matrices there. Yes, I gave you some really basic examples, but basically it's a little bit more advanced, but you can use matrices for those examples as well. So this is what a matrix is. Now what type of operations you guys can perform with a matrix? So with a matrix you can perform, for normal numbers, you can perform four types of operations. You can perform an addition, a division, a multiplication, and a subtraction. When you guys are working with a matrix with rows and columns, there are three things that you guys can do. So basically, the first type of operations would be row switching. So it's when you guys are performing row switching operation. I'll show you the examples a little bit later. So when you guys are performing row switching, it's really important to focus on copying the right numbers exactly, because you will have a mistake after that. You can perform an addition, so basically additioning matrices together, but once again you need to have the same matrices. So basically here you can have an example. And finally you can perform a multiplication in matrices. So let's start with the first one. So basically row switching looks something like this. So as you can see, what we have done here is pretty simple. So we just took the first row and we put it at the end right here. So basically what we've done, we simply changed rows. So this is permitted to do when you guys are working with matrices, and then you can use this matrix and make an addition of this matrix to another matrix, for example. And it's going to be pretty much the same thing. So as I said, the second type of operations that you guys will perform, or you can perform with matrices, will be the addition. So in this case, we'll have an addition right here, so it's pretty simple to understand it. So as I said, really important, the matrix size should be the same. So basically in this case, the matrix size is 2 by 2. So basically it should be 2 by 2, not you cannot make an addition of a 2 by 2 by a 3 by 2, for example. It will not make sense. So here we have a 2 by 2. and you guys can perform an addition. So basically how it will work, so you will addition the first number with the first number right here, the second number with the second number, and same thing right here, third number with third number, fourth number with the fourth number. So as you can see, it's pretty simple to do. Last type of operations that you guys can perform will be, in this case, the multiplication. So it's not that it's more complicated, it's not that complicated to do. It's just you guys need to get used to it. So basically how this would work, so pretty simple. Let's say you have this matrix right here multiplied by this vector right here, since it's two numbers, just one column. So basically, as you can see here, the way that you guys will perform the operation is pretty simple. You'll simply multiply your a by the x, and then you'll make an addition of the b multiplied by the y right here. Then same thing, c multiplied by the x plus d multiplied by the y right here. So as you can see, it's well, it's not complicated to perform those operations, and for matrices, it can be really, really useful. So basically here we have matrices multiplied by vector, but it's possible to multiply matrices by other matrices. And as you can see, numbers can grow pretty much, well, here we have a matrix multiplied by a vector, but if we have a matrix multiplied by a matrix, you will have way more operations to perform. So in this case, quantum computing can be really, really useful when you guys have huge amounts of operations to perform. So this is for the basics of linear algebra, and for the basics of matrices. Well, we talked about some other things about linear algebra in the past few courses, but this is really one of the core things to understand when we're talking about linear algebra. We have vectors, but right now we have matrices as well, and they are a huge part of linear algebra mathematics, so basically of this type of mathematics. So that's it for this class, guys, and see you all in our next class.